Today we are going to look into the different aspects of descriptive statistics, and we are also going to look into the application of different aspects of descriptive statistics using the Jamovi software. So before going into that part where we use the Jamovi software for applying different aspects of descriptive statistics, at first let me give some explanations about the data. So basically in current scenario, data is basically being the new oil. If we talk about the Gulf countries mean Arab and all those countries. In previous time period, they have accumulated a very huge amount of wealth on the basis of the natural oil or on the basis of the crude oil. Crude oil was basically the main reason of their expansion and their accumulation of wealth. In the current point of time, data is basically nothing but new oil. New oil means the country or the company which has very huge amount of data, that country or that company can accumulate a very huge amount of oil. I mean very huge amount of money or very huge amount of wealth. So basically in that perspective we can say that data is the new oil. So suppose a company has a very huge amount of data, that company can grow and that company can accumulate a very huge amount of wealth. So that's how data is important in current scenario. Now data can be numbers, data can be text, data can be images, data can be audio, data can be video, and data can be emojis. In the previous time period, data was only numbers, but in the current period, data is not only numbers and numerics. Text is also a form of data, images are also a form of data, audio, video, emojis, all of these are a form of data. Now whatever we post on Facebook or whatever we post on Instagram, whatever audios, videos or images we post on Instagram or Facebook is actually carrying some information about us, and that can be used as data. Whatever text messages you are actually sending on Facebook or WhatsApp or any other social media platform, all of that can be used as data. So that's how text, images, audios, videos, emojis, all of these are nothing but a form of data. In this video we are going to look into the application of this part only. We are going to take numbers as data and what type of application or what type of descriptive application we can perceive with that data, we will look into it. So basically data is data is of two types, quantitative and qualitative. Quantitative is some data which you can quantify, which you can measure. That data is basically quantitative. If I have to give the definition of quantitative data, then I can say that what you can quantify, something that can be quantified. Okay, so now if I try to give an example of quantitative data, then that will be income of a person. Income of a person is a good example of quantitative data because you can measure the income of a person, you can measure the height of people, weight of people. Okay, similarly expenses, all of these data you can measure. So this is quantitative data. Similarly, there is another type of data that is called qualitative. You cannot quantify it, you cannot measure this data. Qualitative data are those data which you cannot measure. Suppose if I take the example of happiness. Now can I say that I am happy and I am happy by 30 units, I am 30 unit happy, or I am 50 kilo happy? I cannot say that, right? So this type of things can't be said about happiness. So happiness is or if I take the data on happiness, then that can be measured, that can be quantified, right? So basically this type of data is happiness. If I take the gender is also a good example of qualitative data. I can say that gender can be female or male, but I can't measure that, right? Or if I give some another example, suppose a person's location, whether that person is living in rural area or the person is living in an urban area. This type of data you cannot measure this type of data. So this type of data are called qualitative data, like gender, location, happiness. All of these data are qualitative data. Now this qualitative data is also known as categorical data. Okay, categorical data are nothing but qualitative. Now this qualitative data can be explained on the basis of two terms, or can be divided into two categories or two types. One is nominal, another one is ordinal. And the numeric data, which is quantitative data, can be divided into two parts, interval and ratio. Now let me take the example of nominal and ordinal. Suppose if I take the gender, suppose I have data of 10 people and I have collected that data. I have their salaries and I have their gender. So the first person is female, her salary is 10k. Second person is male, her salary is 20k. Third person is female again, her salary is 10k. Fourth person is male again and her salary is 15k, suppose. So basically this female or male, this data which I have obtained, the data on gender, in this data we have only information about the gender of that people, whether the person is female or the person is male. We can't tell anything more about this data. So this gender is nothing but nominal. This data type is called nominal. So what is ordinal then? Ordinal is basically nothing but a nominal data, but in this type of data we can rank the data. Like if I take the example of gender, I cannot rank the females or males, right? I cannot rank that. I cannot say that male is superior and female is not superior. I cannot say that that female is inferior and male is superior. That kind of interpretation I cannot draw, or that kind of conclusion I cannot draw. But suppose there is a degree given on salaries and education, educational attainment or educational degree. Now if I take the example of educational degree and salaries, then the person who is educated up to class 10, then a person who is educated up to class 12, then a person who is coming, that is graduate, and then a person is coming who is postgraduate, and then a person who is coming who is PhD. Now this type of data can be ranked. If I give rank 1 here, then class 12, the person who is educated up to class 10 will obviously inferior to a person who is educated up to class 12. So I am giving rank 2 this, then rank 3 to this, rank 4 to postgraduate, and rank 5 to PhD. In this way we can rank our data, okay, which was not possible in the case of gender. In the case of gender we can't rank our data, but in case of educational degree or in this type of scenarios we can actually rank our data. So when we can do the grouping of our data and we can also rank that, then that data can be termed as ordinal data. Okay, so this data division is very important. This division is very important to understand, that when we can rank the data, suppose if I try to rank the level of teachers, then at first comes the school teachers, I can rank them 1, then comes the assistant professors, I can rank them 2, then comes the associate professors, I can rank 3, then the professors, I can rank them as 4. So this type of data, so you can rank the data, and one rank, I mean suppose if I take 2 ranks, then the greater rank will be superior than the previous one. That means if I take this example here, the PhDs, the student who is educated up to this PhD level will obviously be superior than the postgraduate level. Similarly, this postgraduate level will be superior than graduate level. So in this type of ranking you can actually do the comparison, and one rank or one level is superior than the previous rank. So when we can create this type of ranking, then that data is nothing but ordinal data. What is the example of ordinal data? Educational attainments or educational degrees. Similarly, level of teachers. That can be also an example of ordinal data. And what is the example of nominal data? That is gender or the location of a person, whether the person is living in a rural area or an urban area. In this type of data you can rank that. I can't say that rural area is superior than urban, so I will rank rural 1 and urban 2. That is not possible, right? Rural is obviously not superior than urban. I mean, that type of interpretation is totally wrong if I take. Now let's come to the next two parts. Numeric data are divided. Numeric data are, we may also call it quantitative data. Quantitative data or numeric data can be divided into two parts, interval and ratio. Now what is interval and what is ratio? Basically they are quantitative data, so they will be numbers. They can be represented as numbers. Like if I take the example of weight, if I take the example of height, then this type of data can be interpreted by the basis of numbers. 2, 5, 6, suppose 2, 20, 50, 60. 2, 5, 6 will be very less amount of weight. In case of height, I may give 5 foot 5 inch, then 5 foot 9 inch, 4 foot 2 inch. Okay, now the point here that is arising, which type of data will be interval and which type of data will be in ratio. So basically if we talk about interval, then below 0 value is possible. Then the value can be 0, less than 0. The value can be less than 0. If there is a data on which we can get negative values, if there is a data on which we can get negative values, then that data will be going into the interval, or we also call it interval scale and ratio scale. So that data will be going into interval scale. So if I have data on temperature, suppose, then temperature can be 40, 30, 0 degree, and temperature can also be minus 20 degree, which we can observe. So this type of data are possible to be negative. So this is nothing but going into the interval part. And what is ratio? Here the value will be positive only. Negative value is not possible. The value can range from 0 to positive values. Any positive value can be possible in the ratio, but negative values are not accepted in ratio. So just like if I give an example of height of a people, now height of a people can't be negative, right? So if I am talking about height, then that is going into the ratio scale, not in the interval scale. But obviously ratio and interval both are quantitative data. So I hope I am being able to clear the difference between interval scale and ratio scale. In interval scale, negative value is possible, and in ratio scale, negative value is not possible. The values will be positive or 0. Okay, now as I have said, data can be quantitative and qualitative. In qualitative data we have nominal and ordinal. In quantitative data we have interval and ratio. Okay, now the concept here that is arising here, that the level of measurement, we have studied the level of measurement here, right? So the level of measurement, we have labeled the data as nominal, ordinal, interval and ratio, or we may say that we have labeled the data into the part of qualitative and quantitative. Why is it important? Why labeling the data is important? I mean, why are we giving these labels of quantitative and qualitative? What is the importance of it? So basically we know there is central tendency, measures of central tendency. In measures of central tendency we know some measures like mean, we know median, we know mode, right? So basically this mean, median, mode, these are the measures of central tendency, and there are some measures of dispersion as well. In the measures of dispersion we basically take range, SD, variance, quartile range, interquartile range, quartiles, percentiles. Now the question is, on which type of data we should use mean? All of these are central tendencies, right? Mean is a central tendency, mode is a central tendency, median is a central tendency. On which type of data should we use mean as a method of central tendency? On which type of data should we use median as a measure of central tendency, and on which type of data we should use mode as a measure of central tendency. That question is important, right? Similarly, if we take a call about the dispersion, on which type of data should we take the measurement of range as a measure of dispersion, on which type of data should we take the SD as a measure of dispersion. So knowing these things is very important, right? Similarly, we know different type of plots like bar charts, scatter plots, box plot, right? Now, on which type of data should we use bar chart, on which type of data should we use scatter plot, on which type of data should we use box plot, that knowledge is also very important. So that's why we have labeled our data in different parts. Okay, so let me clear this, but before going into that, we know that statistics has two parts. One is descriptive statistics, another one is inferential statistics. Descriptive statistics does nothing but it describes the data. It describes the data, and that description can be given in a graphical manner, or it can be also given by mean, median, mode, and standard deviation, variance, and all that. Okay, so basically descriptive statistics are the statistics or that part of statistics which gives us the description of data, and it also helps us to understand the data, gives a presentation of the data, and it also gives us a summary of the data. An inferential statistic, in this statistic we basically try to get a sample from the entire population, and on the basis of that sample we try to get an idea about the population. I mean, suppose that sample is giving us a mean of 10, then we get an idea that the population will also have the mean around 10. Okay, so suppose this is the population of India, that suppose this is on 50 billion, 1.4 billion, sorry, 1.4 billion. Suppose this is the population of India, 1.4 billion. I have collected a sample of 5,000 people. Now their average salaries are being calculated. So from this 5,000 people, I am observing that their salaries are 10k rupees. So I can infer that the population or the entire India, all the people of entire India will be having a average salary around 10k. So that kind of inference can be made on the basis of the sample that are being drawn from the population. This is a part of inferential statistics, which is very popular in statistics. Here we are going to just deal with this descriptive statistics. If you require knowledge about inferential statistics, then I will make a video another day. Now here we can also calculate the variance of from the sample. From that we can also get the idea about the variance of population, right? SD, range, all of that we can get an idea. So here notice the topic, that is not the topic here. I am just going to discuss about central tendency. So in central tendency, mean, median, mode are the central tendencies. So basically we all know about this. Suppose if I have the data points, these are my data points. So what is central tendency telling us? Central tendency is telling us that there will be a value in the middle. There will be a value in the middle of these data points, and that value is nothing but a measure of central tendency. And that value can be mean, that value can be median, that value can be mode. So that middle value is nothing but our measure of central tendency, which can be mean, which can be median, which can be mode. Now which one we should use on which type of data? That is the important question we have to answer. I hope we all have some idea about mean, median, and mode. Mean is nothing but the sum of all the values divided by total number of observations. Median is nothing but the middle value. Suppose if I have 5 data points, 3, 2, sorry, I should suppose I have 5 data points, 3, 2, 6, 9, 3, suppose 1. Then I have to arrange it in a ascending order or in a descending order. So it will be 1, 2, 3, 6, 9. Now the middlemost observation will be our median. If we have more than, if the total number of observations are in odd, then the middle number will be our observation. If the total number of observations are even, that is suppose we have another number 12, then we have to take the average of middle two values, that is 3 and 6, and we have to take the average of 3 and 6, that will be our median, that will be 4.5 will be our median. In case of mode will be our most frequently occurring value in the data set, or the data on the point which has the highest frequency. Suppose if I have 5 data points, 2, 3, 4, 2, 5. Here 2 is coming twice, or I feel, let me give 3 and 4 and 3 again. Here if you examine that 3 is coming 4 times, 3 is coming 4 times, right? So 3 will be our mode. This 3 will be our mode because it is occurring, or it is coming most frequently. It has the highest frequency. It is coming first time here, second time here, third time here, and fourth time here. So it has the highest frequency, so it will be our mode. So mode is nothing but the most frequently occurring value in the data set. So this is the concept of central tendency. Now let me clear the part of dispersion. Now after clearing the part of dispersion, I will go with the flow that what type of measures should we use in what form. This is given here in nominal scale, in ordinal scale, in numeric and normal, and numeric and non-normal cases. What type of central tendency and what type of dispersion should we use? I will come to that. But before going into the part of mode, let me clear a thing. From a very young age, we basically know that we have an idea about average from a very young age, and we know that average is nothing but mean, or it is not the point. Actually, average is not only mean, median, mode, all of these are basically average. Mean and average are not the same thing actually. Median is also average, mode is also average. It is depending on which type of data are we taking. Okay, in a normal distribution, I will clear the idea of normal distribution in the later part, but in a normal distribution and in a nominal data, sorry, not nominal, in a normal distribution and in a ratio scale or in a numeric data, average is mean. But if we are taking categorical data, then average is becoming more median, not mean anymore. Okay, so basically from a very early age, we basically know that average is nothing but mean, but that is not true. Average can be median also, average can be mode. It is depending on the type of data. What type of data are we dealing with? That is the that is going to give us the idea that what is the average that we are talking about. It will not always be mean. Now dispersion is actually going to tell us that how much spread is there in our data. Suppose this is my data sets and these are the data points, right? So this is the middle value. Suppose this is the middle value. Now how much spread is there in our data set? The points, data points, how much spreaded they are. This is going to be examined by the help of dispersion or measures of dispersion. We have multiple measures of dispersion. Now this middle value can be mean or median or mode, anything. Okay, that depends on the type of data. This middle value is not only mean. Don't be mistaken that this middle value is only mean. It can be mean, it can be median, it can be mode, depending on the data set. So how much spread is present in our data set or in our data points from this middle value or from this measure of central tendency, which is mean, median or mode, that is going to be told by measures of dispersion, which are range. Range is nothing but the maximum value minus the minimum value, x max divided minus x mean. This is our range. Interquartile range is nothing but if we divide our entire data set into 4 parts. Okay, so this is our start. This is the first part, which will have 25% data points. Here we have 25% data points. Here we have 50% data points till Q2. Till Q3, here we have 75% data points, and till Q4 we have 100% data points, although Q4 is not important here. So these are the 4 quartiles. Okay, so Q2 is nothing but median, as you can understand that the 50% data points are actually within Q2, so Q2 is nothing but median. Interquartile range is the range between Q3 and Q1. So this is basically Q3 minus Q1. This is the interquartile range. Okay, this middle portion is nothing but IQR or interquartile range. Variance is average of deviations, standard square deviations from mean, and standard deviation is the square root of it. Variance can be expressed as summation xi minus x bar, um, summation xi by x bar whole square by n in case of population, and in case of sample it is summation xi minus x bar whole square by n minus 1 in case of sample, and standard deviation is nothing but root of it, square root of it. Now which type of data is going to give us, I mean to say, I am trying to explain here that what type of measure of central tendency and what type of measures of dispersion should we use on which type of data. If we have nominal data, nominal data means, I hope your intuition is clear about the nominal data. Nominal data means only that type of data where we can group it, but we cannot give any rank like gender. We can group it by saying this person is female, this person is male, but we cannot rank it. So in this type of data, the central tendency will be mode, and there will be no measure of dispersion that we can apply. In ordinal data are the data where you can create a rank, or you can give a rank to the data set, like educational levels. Here the central tendency is median, and the measure of dispersion is interquartile range. In numeric and non-normal data, the central tendency is median and dispersion is interquartile range, and in numeric and normal data, the central tendency is mean and the measure of dispersion is standard deviation. Now what is normal? Basically, if we create the PDF, or if we create the probability density function of a data point, and it looks like this, bell shaped, so that type of data is normal. When the data, how to create this, how to check this normality, I will come when I will open this Jamovi software, then I will come into that. But for now, just know that if the data has this bell shaped and the data is symmetrically distributed on both the sides, the data is symmetrically distributed, it is not skewed, then it is normal, and then we will use mean as the measure of central tendency and standard deviation as the measure of dispersion. If the data is right skewed means the data is basically the right tailed, the data is right tailed here, as you can see. So income can be a good example of this. If I take this example, suppose 1k, 2k, 5k, 10k, 1 lakh, 10 lakh, this is the monthly income of people, then very few people will have this income of 10k, right, 10 lakh per month. So as you can see, most of the people are having the monthly income of around 5k to 1k to 5k in India. Very few people are having this income of 1 lakh to 10 lakh monthly. So this type of data points, there are very few data points are actually on the right tailed. This type of data points are basically right tailed or positively skewed distribution, or this type of data points are showing positively skewed distribution. This is not normal, this is positively skewed and right tailed. Similarly, we may have also left tailed distribution like this, okay, where the tail is on the left hand side. So in this type of data, they are not normal, they are non-normal, and we will use median as a method of central tendency and interquartile range as a method of dispersion. And if we talk about this is another slide that you can look into, it is the same thing which I have described. If we talk about the charts, before going into the parts of the charts, I will be willing to before going into Jamovi, let me clear this. Let me give an idea about box whisker plot. Box whisker plot is basically a plot which is a 5-point summary chart. 5-point summary chart means it gives us 5 things. This line will be giving us the value of median, which will be automatically given in the software. You don't have to draw this line, it will be given. So this is the first thing which is being given here, median. This point is Q1, 25th percentile, or this is Q3, 75th percentile, you may also call it 75th quartile. This is IQR, the difference between Q1 and Q3, as I have shown earlier. Q1 minus Q3 or Q3 minus Q1, this difference is IQR or interquartile range. So this is the first thing, this is the second thing, this is the third thing, this is the fourth thing given in the data point. What do we call Q1, Q3 is also not that important. The minimum value is also being given. Minimum value is, it is not minimum point from the data points. It is not the minimum point of all the data points. It is nothing but the minimum level. And if any data point is below the minimum level, as you can see, this data point is below this minimum level, so this is nothing but outlier. Similarly, as any data point, if any data point is above the maximum level, then that will be also outlier. And minimum, how to find out this minimum level? That is nothing but Q1 means 25th quartile minus 1.5 into IQR, that is interquartile range. Similarly, Q3 plus 1.5 IQR will be our maximum level. If any data point is above the maximum level or minimum level, then that is outlier. So that is the concept of box whisker plot. Now if we have scale is nothing but numeric. If we have numeric data and we have only one variable, then we will take the help of histogram and box plot. If we have categorical data and we have only one variable, then we will take the help of bar chart or pie chart. If we have only 5 variables or less than 5 variables, let me correct it. If I have only one variable, but if I have 5 type of observations, then I will take the help of pie chart. Otherwise, I will take the help of bar chart. I mean to say, if I have more than 5 categories, then I will take the help of bar chart. Otherwise, if the categories are less than 5 or equal to 5, I will take the help of pie chart. Okay, so this is the concept of one variable. But if we have more than one variable, suppose we have two variables. First variable is scale or numeric and second variable is also scale or numeric. Then I will take the help of scatter plot. First variable is categorical and the second variable is numeric or scale. Okay, then I will take the help of side by side box plot. Similarly, if the first variable is categorical and the second variable is scale or numeric, then I will take the help of side by side box plot. And if the first variable is categorical and the second variable is also categorical, then I will take the help of multiple or stacked bar chart or bar plot. Now in the side by side box plot, it is nothing but the multiple box plots will be present there, 1 2 3 4. I will show it, but here you have to remember that qualitative data in categorical, if we are drawing or if we are trying to plot this side by side box plot, then we will have categorical data and scale data. We will have one variable which will be categorical and one variable which will be scale, means numeric. Always plot the categorical data on the x-axis and the numeric data on the y-axis. It will be automatically done in the software, but I am just willing to give the intuition behind it. Now let me show it by opening the software of Jamovi. So Jamovi is being started. Now at first what will I do? I will import a data set. Okay, I have opened a data set which is known as, I will go to this browse option, and this is the data set I will be trying to look. There is a data set which I have loaded here. Yes, this is the heart study data. This I will be opening here, and this data set is being imported, as you can see. Now let me show the variables. So there are multiple variables like serum cholesterol, blood glucose. These are nothing but the factors which are going to affect our heart. So no, I don't require this now. So basically these are the variables, as you can see. Physical activities, physical activity. Now let me give the idea about these variables. The first variable is gender. Gender is obviously, now you can tell me gender is what type of variable. Gender is nothing but a nominal variable, right? Education, education, what is what type of variable? Education is nominal or ordinal. Education can be ranked, right? So it is a ordinal variable, it is an ordinal variable. Gender is a nominal variable, education is an ordinal variable. Now I hope it makes sense. Weight is a numeric value, or more precisely we may call it ratio, because it can't be negative. Height, it is also a numeric value. Okay, so this, all of this can be termed in this way. Now smoking is also a nominal variable, right? It can't be grouped. Physical activity, here physical activity can't be physical activity is given in the sense of, let me see, 1 and 2, 1 and 2, 1 and 2. It is also a nominal variable, because whether a person will be doing physical activity or the person will not be doing the physical activity. So these are the two ranks we can give. Obviously it is not a rank, it is a nominal variable. So 1 and 2. 1 means the person is not doing physical activity, and 2 means the person is doing the physical activity. Similarly in smoking, 1 means the person is a smoker, 0 means the person is a non-smoker. So this is the basic idea about the data set. Similarly gender, 1 means male, 0 means female, and all that. Now what do you want to do here? I will just try to create the plotting. Before going into the part of plotting, let me go into the descriptive statistics. So basically, if I take the part of gender, now you guys tell me, gender is what? Gender is nothing but a nominal variable, right? So as you can see, it is being measured type, it is already being given as nominal, and here are other options also. Continuous means nothing but it is a numeric value. Here the value is not numeric, so it is continuous. Data type integer, all that is given, right? Now if I want to see the exploration part, if I want to see the descriptives, okay, so it will be giving me everything, but I will just take this gender column. Now as you can see, it is giving me everything, but what type of statistics I do want here, that is important. I don't want everything. I know if it is a nominal variable, then the measure of central tendency is not mean, is not median, it is the mode, right? Similarly, there is no dispersion measures that can be applicable to a nominal variable, so I will not select any, I will just be selecting the mode, right? So basically in this way we have to calculate it. Okay, here no value is being repeated, that's why it is being shown as 0. I feel, yes. Similarly, if we take any ordinal variable, then what will be the suppose if I talk about the ordinal variable, then education was there, probably was there education. Weight status, let me show weight status, delete it. Let me show the data. Weight, education was there. Okay, we can do with education. Exploration, descriptives, I feel there was education. Yes, this is the education that I wanted here. Now weight is not required. Now I just, when I am talking about education is an ordinal variable here, so the measure of central tendency will be median, so I will not select this mean, and the measure of dispersion will be interquartile range, so I will be selecting this interquartile range. I will not be selecting maximum, minimum, or standard deviation. So as you can see, median is 2, interquartile range is also giving us the value of 2. So in this way we can find out the measures of central tendency and measures of dispersion along with the variables. Now the question here, that is how to find out whether the data is normal or not. Otherwise, in case of numeric data, we won't be able to fit the central tendency, because in case of numeric data, that question becomes important, that whether the data is normal or not normal. So for that, suppose I want to check on weight. Okay, so basically when I am taking this weight, let me remove this education, and Okay, it is not being removed. Now I am checking on weight. So there is a method called QQ plot. It will be in the plots. If you apply that method called QQ plot, yes, as you can see, if all the points, all these black points are close to the straight line, this 45 degree or this straight line, all these points are close to the straight line or kind of going along with the straight line, then that data is normally distributed. This is the first method that I have given to check whether the data is normal or not. What will be the second method? For the second method, you draw the histogram of the data, and along with the histogram draw the density. When you have drawn the density, you can see that data is looking like to be a normal, like although it's not properly normal, but it looks like still to be a quite close to be a normal distribution, right? The data is looking kind of symmetrically distributed in both the sides, so it looks like kind of normal. So if it is looking like a normal distribution, then what type of method will we apply with this height? So this height, if I talk about the statistics, if it is normal distribution, height is normal distribution, as I have weight, we are dealing with weight was looking like to be a normal distribution, so the measure of central tendency will be nothing but mean. We will remove the median here. We will remove the median, and the measure of dispersion will be SD. So as you can see, we will select SD, and mean and standard deviation is being given. So in this way we can at first check whether the data is normally distributed or not. If the data is numeric and normally distributed, we will take the mean as the measure of central tendency, and we will take the SD as the measure of dispersion, and if it is not normally distributed, we will take median as the measure of central tendency and IQR or interquartile range as the measure of dispersion. Now how to I hope how to plot this box. Let me clear the concept before going into that. Let me see whether my screen recording is working. Yes, it is working. So now the concept is, suppose I want to find out the next part. The next part means, if I go by the PPT, then suppose we have one variable, and that variable is scale. Then we should apply histogram and box plot. So suppose I have multiple variables here, but suppose I want to apply on height. Height is nothing but a numeric value. Okay, so height is nothing but a numeric value or a numeric variable, or you may also call it continuous. So if I select height, what type of plot I will be using, that becomes important. It is a one variable, so here in the plots it is height, so I will be using bar plot. Okay, as it is a numeric value. As you can see, in case of one variable and that variable is scale, that is numeric, then we will be using box plot or histogram. Okay, so I will just select from the plots, I will just select box plot and histogram. I will remove this, density is not required here. So as you can see, box plot and histogram is being given. The box plot is giving us the information that height, in case of height, it is ranging from around 150 to 175, but most of the data points are actually belonging to 158 to around 165. And if we talk about Q2, or if we talk about the median part, then the median is around 162, and from the median and from Q1 and Q2, in between this range, Q1 and Q2, where is Q1? Q1 is here, and Q2 is here, and this is Q3. So in between Q1 and Q2 there are more data points in comparison to Q2 and Q3. So in between Q1 and Q2, which is nothing but median, we have more data points than Q2 and Q3. This is the interpretation, and all the data points are being here from 150 to 175. We may also filter it. Suppose I want to see the mean along with the box plot, then this is the position of mean. This black dot is nothing but mean. Okay, and label outliers. There are no such outliers which are to be. If I want to see all the data points on my box plot, then this is the way to see it. As you can see, most of the data points are actually in between this range from Q1 to Q2 or from Q1 to median. Okay, so this is the concept of box plot. Now suppose I have a variable which is categorical. Categorical means suppose the variable is gender. Okay, now let me remove this height and let me put gender here. And what type of plot we should use in case of gender? So let me show you the PPT again. In case of gender, and gender is categorical, it is the only variable, right? And that is categorical, so we will use bar plot or the pie chart. So basically we will be using bar plot here. So let me show bar plot. Gender is obviously categorical, but it is not a good example to show. Let me show it with something else, like smoking or education will be a good example to show. Although we can do it with gender also, but if we do in case of gender, then we are just taking the bar plot, nothing else, not this box plot, not this histogram, nothing else. We will be just taking these bar plots. QQ is also not required. So as you can see, this is the count of gender. 0 denoting male or female, 0 denoting female, 1 denoting male. So there are around 55 people who are female in the data set, and there are total around 45 people who are male in the data set. So this is the concept of using the bar chart in the categorical data. Now suppose we have two variables, one is scale and another one is also scale. That means both of these two variables are numeric. Now what should we use? We should use scatter plot, but let me choose two variables. One variable is height. I will choose height. Let me remove gender, and other variable will be weight. So in this data set, what type of plot we will be using? We will be using scatter plot. Okay, so scatter plot will not be coming by default, probably we have to download it. So I feel we have to go to the modules and manage installed, and scatter, I have to use it. It was already installed, so I don't know what is happening here, but let me see that whether the scatter plot was available here or not. Plots, if I go to the plots, no, the scatter plot is not available here at this moment. I hope there will be some problem with this, but I hope you may have understood how we actually have to plot the scatter plots. Similarly, I feel there are some other values. Okay, whatever. At this moment, scatter plot is not available here. Let me see the change if I can make. Exploration, yeah, it is in this. Sorry, I was actually looking into a wrong tool. In this way you can actually find out the scatter plot. So for finding out a scatter plot, we will just take the weight on the x-axis, and we will take the height on the y-axis, and we will group. Our group is not required. As you can see, weight and height is being given. And if I want to take suppose if I want to take a regression line, then that best fit line will also be shown here. As you can see, this is the best fit line. If you want to fit a smooth regression line, then that can be also given. Okay, so this is the things that you can check. This is the things that you can customize here. So I hope this is clear. Now if I have one variable that is categorical and one variable that is scatter, that is scale, that is numeric. So one variable that is categorical and another variable is numeric. In this situation we will basically be using side by side box plot. So let me pick one variable which is scatter and one other one variable that is scale, that is numeric, and another variable which is continuous or scale. Okay, so for that I will go to the variables option, or I will get to the analysis option, and I will pick up this exploration. Now I will at first pick up two variables. One variable will be categorical, that will be my variable of education suppose, and another variable which will be suppose numerical, uh, though another numerical variable will be suppose blood glucose, although it looks like kind of rigorous. So I just want to fit these variables, and I want to fit a side by side box plot. So now as you can see, if I click on the box plot, it is going to give me two box plots. Okay, uh, if I try to group them, so basically suppose I have a variable weight, and I will not basically select it. Suppose I have a variable education, and if I take this glucose out and I will just split by gender, I'm just taking the gender and education. Then if I create the box plot, now it is going to give me the side by side box plot. As you can see, the side by side box plot, this is giving me some idea about the education among the genders, among the males and females. As you can see, in case of females, there are the education is actually from rank 2 to rank 3. That means most of the education is from what is the level of 2, probably it was higher secondary to graduation. And in case of males, it is from the Q1 is starting from the initial level, obviously, that is the secondary, probably secondary level of education, and it is going up to higher secondary or graduation level, the Q3. And there is an outlier here also present in the female case. So this outlier suggests that there is a one extreme value which was above the maximum level, and that girl has achieved education of at least PhD level. Okay, so this is the interpretation of side by side box plot. So by this method, by observing the different labels of variables or labels of data, we can actually create different types of interpretation or different type of plots and different types of measures of central tendency and measures of means, as I have shown here. So this is the last thing that I want to revise once more, that is, if I have only one variable and that is a scale or numeric variable, then I will draw histogram or box plot. If I have only one variable and that is categorical, I will draw bar plot or pie chart. If I have only two variables, both of them are numeric or scale, then I will draw scatter plot. If I have two variable, one is scale, one is categorical, then I will draw side by side box plot. And if I have both categorical variables, then I will draw multiple or stacked bar chart. This is the concept of today's video. I hope you guys enjoyed it.